Section 9.4, Current and Magnetic Fields. So magnetic domains that occur inside of metals like iron, where you have all of the atoms align, when that happens, you have a large magnet. A similar type of alignment occurs when you have electrons moving inside of a wire. Those electrons are exposed to an electric field due to the potential difference in the circuit. And because of that electric field, the electrons align, and when they align, they generate a magnetic field. And so you find that there is a magnetic field that is around wires that carry current. And the magnetic field goes around in circles around the wire. And so if you form a loop in the wire, you can see that the circles that go around the wire, they start to kind of pile up towards the center. If you double this loop, more and more of these circles, more and more of these field lines will pile up. And so if you put more and more loops in the wire, then you have more and more magnetic field lines, and you generate in between all of these wires a very strong magnetic field. That magnetic field is affected not only by the number of loops in the wire, but also by the current in the wire. So if you were to increase the current, you could increase the magnetic field. And if you increase the number of loops in the wire, you can increase the magnetic field. So we can then use this idea that we can generate very strong magnetic fields to turn other objects that are not wires into magnets. So if we take a piece of iron and place it inside of a coil of wire, and you crank up the current on the wire, the magnetic field that's generated in the iron will align the atoms, causing it to become magnetic, just as if it was connected to a very strong magnet. These are what are known as electromagnets. You can affect the strength of the magnet by changing the current in the wire. The process of generating electric fields and electromagnets is used to propel magnetic trains, and it's also used in particle accelerators.